Three people are presenting? Oh, I turned on AI? I don't like AI. No one's gonna ever read it. Okay, okay, we have three presenters. Okay, well,
Make it quick, huh?
yeah, try to, right, try to keep, uh, this shrink. Okay, everybody waits till then. Uh, okay, so here we are. Okay, you want to go? Okay, so we're ready for a presentation by, I'm not sure where your thing.
Oh, the AI.
Okay, whatever, you'll do it. I should get maybe get them now.
Okay, I'm just gonna go with my speaker notes.
Fintech. Oh, cool.
Okay, so today I'll be talking about artificial intelligence in transforming the fintech industry. And so first, what is fintech? Fintech stands for financial technology. It includes tools and services like online banking, mobile payments, Venmo, Cash App, digital investing apps like Robinhood, and fraud detection systems used by banks. The main goal of fintech is to make accessing and managing money faster, easier, and more secure. And now, where does artificial intelligence come in? So, AI has become one of the biggest drivers of change in fintech because it can process huge amounts of financial data more quickly and more accurately than humans. AI can recognize patterns, make predictions, and automate decisions in real time, which is incredibly valuable in the financial world. One of the major areas of that AI is transforming is security and fraud detection. So banks use AI to constantly watch for unusual spending habits, like a sudden charge in another country, and block suspicious transactions instantly. This protects customers and helps companies reduce the billions they lose each year to fraud. Another important application is customer service through AI chatbots. So if you've ever had used the help feature on your banking app and got faster answers, that likely came from an AI assistant, and these systems are available 24/7, can handle thousands of customers at once, and continue to improve the understanding of human language. And also, AI is improving lending and credit decisions. So, traditional credit checks often disadvantage people without long credit histories, but AI can analyze many more data points like payment behavior, income patterns, and even phone bill payments to determine if someone is creditworthy. And this helps making lending more inclusive and expands access to financial opportunities. And then we have personalized banking and investment. So, robo-advisors use AI to build customized investment plans based on customer goals and risk tolerance. And apps can now recommend saving strategies, notify you if you're overspending, and help you make smarter financial decisions, almost like having a personal advisor at all times. Um, so these advancements come with big benefits. Transactions are faster, banks save money, fraud drops, and customers get more tailored and accessible financial services. And AI is even helping people in underserved communities get financial support they may not have had access to before. But however, there are also some challenges. So AI systems can sometimes learn from biased data and make unfair decisions, especially in lending. So data privacy is another concern. Since AI relies heavily on personal financial information, protecting that data is extremely important. And finally, automation may reduce certain jobs in traditional finance. So companies have to balance innovation with workforce support and new skill development. And as for the future, looking ahead, AI will continue to expand in fintech. We may also see fully automated financial systems where saving, budgeting, and investing happen automatically in the background. And AI is also expected to work more closely with blockchain technology to make payments even more faster and more secure, possibly changing the global financial system. And just to wrap everything up, artificial intelligence is improving financial services by making them smarter, more efficient, and more personalized. Although challenges like bias and privacy need careful attention, AI is helping create a future where money management is simpler and more accessible for everyone. And yeah, thank you for your attention.
Wow.
It's crazy because currently we're at my job, we're doing something like AI integrated.
I'm sorry?
Currently on my job, we're also doing something with FinTech, like integrated with the AI, but like, we're creating a whole AI chatbot.
Oh, really? I always ask those chat things, and are you a person?
They're not.
Do they lie? Or
I mean, like, they are very transparent, but like, it's like still no person. We just rolled it out like today.
nothing, but if I ask them, are you a real
Oh, they're not,
person?
yeah, they're not gonna say they're a person.
They won't say.
No.
So I always say that, and if they're not, I just, quit. I want to talk to a real person. Okay, who's next? It was very good, by the way. But, oh, also, like, I read somewhere that, in China, they did like a lot of AI, and they found out that people
Sorry.
who use their, like, apparently in China, it's very easy to borrow money, like on your phone. And they found out that people who borrow money, the people who don't charge their batteries, those people are bad credit.
Use their device, they're like running on empty.
Yeah, like they're nearly like 2%. Those people are bad credit risk. So they found the
Like
correlation.
another like data point, like data source to
What?
like another data source, like how I into like people with not long credit history have another way of getting judged for like,
Yeah, well, I think they measure about 250 things, but what, like how fast they type. Also, like, if someone asks for money confidently, then that's a sign that they intend to pay it back. But if they do it slowly, it keeps it, right? So they look at all those different factors and they correlate it. Okay, that's that.
No problem. Okay, my name is David Fazlov, and my presentation today is on 5 examples of bad website design and how can they be improved or done better. So I'm first going to introduce why good design of a website actually even matters. Why is this relevant? So it's relevant for 2 reasons. One is user retention, and 2 is brand credibility. So
one more time, what's your topic?
it's on 5 examples of bad websites. Yeah, bad website design. So why good design actually matters is for 2 reasons, for user retention and brand credibility. So there was a study done by Google actually in 2012 that showed that first impressions, when someone first enters your website, 94% of the first impressions are actually design related. So users are actually able to form an opinion of your website and how well it's designed within 50 milliseconds or so, and they'll decide whether or not they actually want to stay or leave. So if it looks very poorly designed, user retention immediately plummets and they just want to get out of there. They're out. They will leave. And another study was done by Stanford that 75% of consumers,
50 mils.
yeah, they just look at it and it just looks bad. They just want out of there.
It's kind of a crazy number. Yeah. Okay.
Yep. And then this study was done by Stanford that stated that 75% of consumers admit to just making a judgment on a company's credibility just based on their company's website design. So they'll look at it and they'll make a judgment, even if the business is flawless and good. If they look at their website, they think, it's poorly designed. I don't think the business is credible. I'm going to take my business somewhere else. So these are 2 reasons. So here's the first example of a bad practice, clutter. If you look over here, this looks like an Epson website, right? And it's just overloaded with so much information. And it's hard to actually navigate through a website like that because it increases your cognitive overload. You're trying to figure out what to do. The user experience should be good. The user interface should be solid, simple, and basic enough to use that it's accessible to everyone. So the problem is you're trying to say too much information. You're not spreading out your information. So this overcrowded interface can cause that cognitive overload and makes it very, very difficult or even impossible for users to know where to look or click to find what they're looking for. And so the fix for that is using more white space to separate the elements and help guide your user through. Make it as simple as possible and easy to navigate. So prioritize things like content hierarchy, which are the most important things, should be shown to you first so you know exactly where to go. And this just shows clarity score and the difference between a good or a bad website and a somewhat good or usable one. So clarity score is just a measure of how easy it is for a user to understand a web page as soon as they look at it. So as we could see here, this has a clarity score of 10, which is very, very hard to use. And as we said in the previous slide, that means much less user retention. People are just going to want to leave that website. Medium clarity score is just some structure, but it's still difficult to interpret. There is some cognitive overload there. And 60 to 100 is a high clarity score. So that means it's just really easy, clean, simple to use. Then confusing navigation. So there's this concept called mystery meat, which is basically just a button that you don't know where to lead you to. So if you're creating basically labels or tabs or buttons, and the user doesn't know where they lead you to, it's basically meaningless. It's just burying information. And users don't want that kind of experience. They want to adhere to something called a 3-click rule. So users should find what they need in 3 clicks or less, ideally. So use descriptive labels, things called breadcrumbs. This term is actually from Hansel and Gretel. So it's kind of let's say you're lost in a forest, you should be able to backtrack and find where you came from. So you want your site to be simple enough and easy enough to understand so that I could always find my way back. Let's say you're on Amazon, for example, and you could dive deep into items, right? You want to find your way back to the homepage sometime. Otherwise, you just get lost, right? So that's what breadcrumbing is about. And use more descriptive labels and ideally a prominent search bar so you could just find what you're looking for immediately. And then speed. So this is what we were talking about kind of in class in some of the few early lectures about performance, right? We want our websites to be snappy and quick. So the way to do that is just by compressing any media that you have. So instead of large high data items, you just make them a lot smaller and compress them, and also implement something called lazy loading. So lazy loading is just load the images that you absolutely need as soon as you just enter the website, and don't bother loading everything else until you actually need to see it. This way, it just makes the experience much faster. The next is mobile neglect. So the problem here is, let's say you create a desktop site first, but now you want to open it up on a mobile phone, right? But the issue with that is that everything on the desktop native is essentially a lot smaller, right? So you just have a lot more columns on a desktop website. And if you try to convert that into a mobile, it just looks like it's not backwards compatible at all. It just, you have to zoom in just to find what you're looking for. It's hard to click on buttons. So it's a UX failure more than anything. So what you should actually do is the mobile first strategy. So ensure that the layouts stack vertically on the small screens first. And it's a lot easier to scale up than it is to scale down. So that's the reason behind it. So make sure that all the text is legible without any unnecessary zooming, and your touch targets on your phone should be easy enough or large enough for your thumbs. So implement a mobile first strategy instead of neglecting the mobile. Lastly is poor accessibility. So let's have a look at these images here. You could see that the gray on the gray, not very ideal. It's low contrast, right? That's a bad practice. So it makes your content relatively unreadable for a user. What you actually want is to follow these website content accessibility guidelines. And basically what this contrast ratio of 4.5 to 1 is saying, you want your text to be 4.5 times brighter than your background. So this way, there's a high contrast and it's a lot easier to read what's on your website, as we could see here. So high contrast color, if we have, let's say, blue on a black background or blue on a white background, it's a lot easier to read versus having, let's say, a gray on gray or a dark, like a darker grayish on a black background, right? It's just not very ideal. And then use something called scalable typography. So basically, if you're on a website, you should be able to go, let's say, on your mobile phone and see, okay, like the text size should change, right? You want your text size to be just like changing snappy at the moment, so you don't have to sit there and zoom all the way through. And always include descriptive alt tags. So this is ideally for accessibility purposes, right? So if someone is visually impaired, let's say, they have something called descriptive alt tags in order to basically read out to the user what that image is describing. So for whatever reason an image doesn't load on your website, you have these descriptive alt tags to actually read out. So you want good quality descriptive alt tags so that everyone could access your website. Okay. And so here's my key takeaways. So simplify, just use the key term Biagni. So if you aren't going to need it, don't include it, right? There's no point of having something for a rainy day. If it's not usable for the user now, just don't include it. Include it when you actually need it, right? And then adapt. Design for mobile devices first. Ensure that your site works seamlessly on any screen size. And lastly, just optimize. Make sure that your performance is up to par with standards, and you'll have a much better time keeping your users' time and attention. And that's it, just some sources that I include for the images.
You can also do caching, I think. I'm not
Yeah, caching, absolutely. Yeah.
sure how that works.
Um, okay.
You
Thank
know how
you.
it works, caching?
I learned in like computer architecture in the sense of how caching works, not necessarily for the web design portion of it, but
Uh,
yeah.
you mean operates,
We learned it in computer architecture, like how cache systems work.
uh,
I don't
um,
know. Yeah.
I guess
Yeah.
it's, you mean like for, not like.
But yeah, basically it's just like
Large file?
yeah, so basically instead of like going back to main memory, at least the way that I remember it, you would just go to the cache system for the most recently used stuff. So it's actually a lot quicker. It's like 1 nanosecond or something instead of 30 nanoseconds to go back to main memory. So you just pull from the cache for the most like kind of like that, yeah. Okay.
That's when where web browser could cache.
I'm sure it's like a similar ideology, right?
I don't know. See, I don't know how much can, like, web browser, I don't know. I guess they carry their own cache, right?
Yeah, yeah, probably. Because we could clear the cache as well. So I'm assuming it's something
Is
similar.
that deep,
Yeah.
so they could cache websites, so.
Well, the guy that made Instagram said that one of the strategies he used for quick accessibility was when somebody was logging in
Mhm.
and they already put in their username, they started downloading their profile in the background because the probability that somebody when they put in their username will actually successfully log in was so high. That
Okay.
it was just a better experience to the user that they already had
Oh.
ready.
Oh, that's cool. Okay.
Same with posts. Once they like put their post and they were about to caption it, they already loaded it as if they were gonna post it because chances are that once you're writing a caption, you're gonna post it super high.
People
Nice.
would say, in the browser, they'll, to a website that you've been to before, so.
Like kind of like preloads it already. It has like some kind of memory.
It's like you copy of it, so this little red one,
Yeah, probably. Right, that makes sense.
this one,
Anyways,
okay.
thank you guys.
Yeah, very good. Okay. You, next? Yeah. By the way, web servers do that, they remember the last query,
Yeah,
they keep it in memory. So
That makes
that's
sense.
why it's a lot of times you query a table, the second time you do it, it's much faster. You also. Oh, the smart people. Oh, okay,
oh wow, okay. Common day.
yeah, yeah. Pretty
I'll
good.
try to be very quick then. Wow. Air Canada was just sued for their AI chatbot. It gave wrong information, and they were actually found liable for what their chatbot lies about and hallucinates. So, little fun fact. No, that doesn't work. That's fine. I'll just present it regularly. Okay, so why did Ariane 5 crash? I found out online this is a European rocket launch, so it's actually pronounced like Ariane, but I'm not going to say that. So why did Ariane 5 crash and what could have prevented it? So you can't really see that, can you? Is that better? Yeah, all right.
You could shrink it, you could do, the three dots, eyes floating, meaning that, yeah, no, go down, yeah, there. There you go.
Cool, thank you so much. Okay. So the Ariane 5, Ariane is like a family of rockets that European rockets that went on from the I want to say 80s. That's currently happening right now. The most recent version was put out in 2025, the Ariane 6. But 1996, there was the Ariane 5, it was very new at the time. And it was infamous for the reason that it crashed the failure happened 37 seconds into it, and then shortly after the failure, 39 seconds in, the whole thing crashed. At the time, it was and still is one of the most costly software bugs in the history of rocket failures, right? $370 million dollars, which was before inflation. Now that's like what, $2 billion ish. There was a more expensive one. The Ariane 4 actually had a more expensive one, but it wasn't software. There was a maintenance crew member that left a rag in one of the engines and it went unnoticed, and that caused it to explode, and that was more money, but that wasn't software, that was stupidity. So the main issue here that happened is they were doing a code reuse. They reused a lot of code from Ariane 4 that went untested. So Ariane 4 was very successful. At the time of the creation of Ariane 5, they did run at the same time for a short bit. They'd only had like one crash. In the end, it was the RAG, so there's no software bugs with it. So they reused a lot of the code from Ariane 4, which seemed to go well, and they put it into Ariane 5, but it had different jobs, right? Like even though the rocket launches, they were in different places and they had different trajectories. And For that reason, there were some bugs that went handled very poorly. So the two main bugs was integer overflow. So the biggest issue that you might think that they would check for is the Ariane 5 flight that infamously went down had a horizontal velocity of over 5 times what Ariane 4 did. And despite that, they didn't update the variables to help with it, right? So when the 37 seconds in, when they were calculating the horizontal velocity, the 64-bit floating point got converted to a 16-bit integer and it overflowed and it couldn't handle it. That's bad enough, right? There's an overflow integer error. But worse than that, they didn't set up error handling for it. Their ideology was like, well, if there's no reason to believe that there'll be an error, we shouldn't code in for that idea. So when the error happened, instead of trying to do some kind of like best estimate for what is the velocity, it was a forced shutdown. So since they didn't account for their errors, as you can see these very graphic images here, it went kaput quite quickly. There's also some dead code issues with some stuff from Ariane 4 that wasn't necessary in Ariane 5, but we're short for time. Um, so yeah, the main problem is they reused code from Ariane 4 and then they didn't refactor it. They didn't check like, okay, what are the new scenarios that we're going to face that we could that might make the Ariane 4 code we saw here be bad, unhelpful. So yeah, right here it says there horizontal velocity was 5 times more. So in the official report that was given, they have solutions for all of these problems that were found. So the first one is that you should have a test facility and inject real input data because you can imagine they knew what kind of velocities that they were changing to. They just didn't foresee the issue with those velocities and change in trajectory. So if you have a testing site and you inject the data that you believe to be true, it's going to be a lot less likely that you run into these errors that you don't foresee. Secondly, it has to deal more with the dead code, right? You shouldn't have any software on here unless it's needed, YAGNI. Because for one, maybe you think it's dead code, but it actually isn't. It actually does something you don't want. And two, the more dead code there is, the less likely you're going to be able to see all of the codes when there's an issue because there's so much you're skipping over. Yeah, and three, the third solution adds on to one, right? You should identify what your assumptions are. Like, oh, this integer doesn't need to be raised in bits because we don't need it to be that far. Well, you didn't for Ariane 4, but you might for Ariane 5. The second learned lesson, sorry, this is still in the way, is their error handling. Right, so I think that the second tidbit here sums it up pretty well. There's reason for concern that a software exception should be allowed or even required to cause a processor to halt while handling mission critical equipment. This resulted in the switch off of two still healthy critical units of equipment. So yeah, like I said, not only did they mess up with not realizing that the horizontal trajectory would be so great in comparison to earlier launches, they had it set up so that if there was an error handled, not that it would lead to an automatic failure of the units because they thought it was unnecessary to code in for that. So it's saying here, like, it shouldn't be allowed, let alone required, right? They made it a requirement that if there's an error, it will halt. It shouldn't even be allowed to make that happen, right? So the solutions here is like, first, don't allow any sensor to stop sending best effort. Like, okay, maybe there's an exception, they didn't get the exact number, but maybe in the error handling, you try to get a new estimate and move on. Provide more data. Yeah, and three, provide more data to help. Yeah, so more data is better than worse data. What ended up happening here is because they didn't want to deal with the integer, whatever the handling was got sent as if it was the data for the integer that got messed up. So it started giving it crazy like nonsense data to use for the trajectory that was really meant for trying to like handle the error that they wouldn't handle. So you should err on the side of more data than hoping it won't happen, kind of thing. And here is the source, which is manages the failure report that they put out and investigate. Like when something like $370 million goes kaput in the air, you have a pretty extensive failure report. So here's a failure report and a paper that was written on the issue. Thank you very much.
Hello everyone. My name is Namu Hawk. Today I'll be today I'll be talking about constructor. So constructor is something we all run into while writing code, but there are little things that we don't really think about. The thing about constructor is it can make your life super easy and make your future self and coworker like you, or it can make everything painful, like make your future self hate you, including your coworker. So that brings me to my topic, which is should constructor be code free? So in the next few minutes, I'm going to talk about what that means, why the debate exists, and why keeping the constructor simple is the big win. So, what is constructor's real job? So, quick refresher of what constructor is creating a valid object and getting it ready to use. And that just means you're just setting the starting values for the field, like setting a player's HP 200 or giving user their ID. And you're not really doing any heavy lifting, like calling the database, reading a huge file. It's just like a doorman in the club. You're just checking the ID and letting people in. You're not trying to serve everybody drink because that's somebody else's job. So, so the thing about code free in my topic is actually a clickbait. So we are not writing zero code. We're still coding. We're still doing this .id is equal ID. So what this really means is that no complex logic. So we are not really doing any complex calculation while creating an object. We are not calling the database. What we are doing is simply keeping it fast, simple, and predictable. Just setting value. That's it. So here's an example of what a bad constructor really is. What I call a chunky constructor. So as you can see, in the user class, in the constructor, in the user method, we are saying that not only we are setting the value to ID, but we are also doing a lot of stuff. I did not really write the code because even I don't want to do this bad. So we are so we are so I wrote it in pseudocode form. So we are connecting to the database, running network requests, and doing a lot of blah blah stuff. So the thing about this is, what if the network is down? What if the Wi-Fi is down? What if the database is down or offline? This is simply gonna make the app freeze, which will lead to the app or the code crashing, which is something we don't really want. So so why this is a bad idea is it's brittle, which means it's fragile. It can break easily. Like if you're connecting to the database, and if it's offline, then it's just gonna break. And it's slow because if you're trying to read like a whole file from the internet, it's gonna take a long time, which is gonna cause performance issues. And the last thing is that it's harder to test because you need a whole database running to test this. You cannot write a simple unit test without a database. So, so here's the fix to the previous code I wrote as a chunky constructor. So the fix is that we're simply moving the work. So we are simply doing this.id and getting out. That's simple as it can be. It's simple and dumb and it's fast and good. So, and then we are shifting all the work to the another method called load data, where we're doing all the nonsense stuff. So later we can just call dot load data to do all that. So this is as simple as it can be. So the key takeaway here is that your constructor should build a house, not a skyscraper. Keep it simple, set your fields, and get out. Your future self and your teammate will thank you for it. Thank you.
Right, right, that's the biggest problem is testing, the constructor it has no return value, right? So
Yeah.
how do you test code inside of them? Right, so we have a lot of code, how do you test it, hard to write a test.
Yeah, yeah. Yeah,
Okay.
thank you.
Okay, oh, wow, okay, now we had, okay, we had a lot of presentations, so that's good.
Professor.
Let's switch my glasses.
Professor. Hello, Professor.
Okay, okay, so today we're going to continue with the UML diagrams.
Professor, I do have one
And,
question.
Then we're going to move, if we have more time, we'll go on to the next chapter, which is architectural design patterns. It's not called, or architectural patterns, I'm not sure what they're called. So where are we up to? So go back here. And okay, so we're in chapter 5 of the book. So just a brief review. So this is a use case diagram, right? It shows which activities, it's like we mentioned, is this a low or a high level diagram? This, it's a high level, right? Because why is it high level?
Kind of like grandiose, like ideas of what's happening. You're not actually like
Right.
getting instructions on how it works or what to do or the small details.
Right, it's not that detailed, it's more like, like maybe somebody, a new person joins the team, and you want to give them like a brief overview of how it works, or maybe you want to, on your own, you just want to understand, or just to communicate with other people on the team to understand how it's going to work. So this is a very high level, all right? And this is even higher level. This is, what's this called? A context, a context diagram. So it's basically, it's just showing you again, I'm sorry, this is called a use case diagram, and this is called a context diagram. And this is like really high level. All it really shows is your program and how it relates to the rest of the world, right? Who it communicates with, etc. Right? So this is a really probably the highest level diagram we could do. Then we started with this, which is a activity diagram, and this is getting more detailed, and we're showing how we're still not doing any code, but we're just saying how we want, what we want, in what order things should happen in the code, right? So, and we had like all these fun symbols. So this is where we remember this circle. What does that mean? This solid circle. What does that mean? Right, where we start, and the bullseye over here. What? Right, where we end, right. So the goal is to go from here to here, right? And we have to somehow go through all these arrows and everything else. And the goal is to go from here to there. And sometimes you get more starting points and you get more endpoints. So not every diagram is going to be, only one start point, one endpoint. Then over here, what does this diamond represent?
Make a decision.
Right, decision, right? It actually depends. If it's one going in and two going out, then you basically have to decide, or actually it can be more than two, but if there's more than one going out, then the idea is that we have to either go one way or the other, right? So it's like what's it called? That poem with the road less traveled, but you have to decide which road to go. What?
Yeah.
Yeah, oh, that's what it's called?
Crosswalk, right?
Yeah, what's it called?
Yeah. I thought that was a Forkland Road.
Okay, right, so you have to decide which way, you can only go one way, right? So, right, so you either have to do one way or the other. So that's what, when you have one going in and multiple leaving, or two or more leaving, you have to pick one of them. Another form of this diamond is where you have multiple going in and one leaving. Okay, could you picture that? I don't have a picture of it. Maybe I do. I think I had it down here. So here, for example, you have two going in and one leaving. You see that? Do we see that? The blue thing? So what does that mean? That that means that whoever comes here first continues through this way, in other words, you could come from multiple directions, but you're always leaving the same way, right? So, but there's no wait. In other words, if you come from the left side, you continue right away. If you come from the right side, you continue right away. So so it's a little bit different meaning than the other way around, where one is going in and then multiple are leaving, right? Right, because that would mean that you could go one of those multiple ways, right? Over here means that whoever comes here first will go out the same way, but without waiting for the other way. And then we spoke about, remember this, the swim lane, right? Where basically the swim lane is, forget about the boxes because those are not activities. So it's the state of, they added some more information about the document itself. I guess it's like trying to put showing the document state within a activity diagram. It's like they just threw more information. But the swim lane, what does that show you? It's taking a activity diagram and it's dividing it up by the people who interact with those activities. So the author will interact with these activities, the reviewer with these, and the owner with these, etc. And the prover so the prover, for example, will only interact with one activity. It's sort of like a use case diagram with a process diagram put together, right? It's showing you like not just the activities, but who interacts with them, right? And also the order of activities, right? So, so that would be a activity diagram with a little bit more information. Okay, so that's where we're up to. Any questions so far? Should we look? Maybe I'll just Google one so we could make sure we're good at it. Let's find a nice activity diagram. Activity diagram. And I'm sorry, UML activity diagram. And let's look at images and so for example, over here, we could see at least part of a diagram. You see that that the person is starting over here, right? They input the number, and then then they have to make a choice. Either go to, either do, if the number is odd, they go to the left. If the number is even, they go to the right, right? And then they display odd number, right? That makes sense? If you have 0 minus 1 is negative, yeah. I guess so. It's always going to be true, right? If you have 1 minus, oh, wait a second. What happens if you have 1? This won't work, will it? If you have 1, oh, I'm sorry. Oh, it's odd. Oh, okay, yeah, it will work. Yeah. So basically, anytime you have a even number, you subtract 1, it will end up being odd, and then you're done. So this is like a little diagram to show you how we're going to process the number. It's actually showing you the algorithm itself, okay? Usually we're not showing that. Let's look at something else. Let's see, what does this do? So over here, it's showing you, you want to, you start over here, and it's probably like an ATM, I guess, right? So you want to start over here by the dot, by the filled in dot, and you want to end by the dot with the space around it, or the bullseye. So the first thing you do is check the count. Now, they left out the diamond. There should really be a diamond. I don't know why there's no diamond here. So, because you can either do a withdrawal or a deposit. So they're missing a fork, right? So there should be a little diamond over here. Then then you do withdrawal. And then when you do withdrawal, it's either not allowed or allowed. And if it is allowed, then you take the withdraw amount, you withdraw that amount, and then you update the account balance, and then you leave. And if it's deposit, you just add it, because then it will always succeed, and then you exit. Okay? So so it's pretty, so how is it? Is it pretty obvious how it works? Or want me to do another example, or should we do another example, or you're fine with that? Or let's do one more, and then we'll move on. Let's see. Again, all these things could be really complicated. Let's try this one. Looks nice and complicated. Okay. What just happened? Hello. Oh, I don't know. Oh, here it is. So we start with a create person and animals. So we start over here, then we create a person, then we have a menu where you could decide what to do. So you could either play with the animal, feed the animal, sell the animal eggs, you could show all the animals, or you could quit. So basically the way it works is you have all these, you have basically a menu with 1, 2, 3, 4, 5 options. And if you quit, then you're done. If you say play, then you play, and then you could choose what animal you want to do the activity with, and then you end up going here to this diamond, and then you start over again. So it's a loop, right? So it's actually a pretty good diagram, right? So it shows you how it's going to work, right? You could pick play, feed, or sell, and then you would have to choose which animal, and then you do whatever you wanted to do, and then you go back again. If you say show all animals, then you just show all the animal information. You don't have to pick an animal because you're doing all the animals. And when you finally want to leave the program, you say exit program, and then you're out. Okay? So that's actually, it's a nice diagram. Okay? It shows you the possibilities, and the flow. What's going to happen? I actually like that diagram. Maybe I should copy this. Uh, I don't know. I've been to this website so many times, and they keep on asking me to allow cookies. I don't get it. Okay. Um, okay, so we're up to our next diagram, which is a sequence diagram. Okay, now a sequence diagram looks kind of weird. So it's a the way you read the idea of a sequence diagram is basically these arrows are the messages between these things on top, which are called lifelines. So the idea is that we start at the highest. Basically, it's a sequence diagram, meaning in time. All right, so it's a sequence in time. So we're starting at the top, and as we go down, as time goes by, right? So, for example, over here, we would look for the highest most line, which is going from the view info to this line, which represents the patient info. And then this patient info would send another message to the Mentcare database, and that would send another message to over here, and then there would be a reply message. Let's just do really, let me see if visual paradigm, we could do it. So visual paradigm, here we go. I think it'll be clear if we do it together. Okay, and if you want to make up the example, basically we want to show the messages between the flow of messages between objects. And also, like, in a way, also how long it takes. So because we're showing time. So let me just, oops, that was the wrong move. Oh, let's shrink that. Okay, so let's say we want to do a new diagram. So we want to do a sequence diagram. Okay, so let's do something like this. Okay. Okay, so basically we start with a actor. I don't understand exactly. I guess the actor is somebody outside the system. But let's say it's being there right now, we're starting from scratch. I don't know, what type of diagram should this be? Like maybe a student wants to ask permission um, to to miss class, right? Wants to take has a doctor's appointment, right? So this would be the student, right? And then the student would, now this is called a lifeline over here. So come on. I don't know why it's so hard. I don't know what that means. Let me just do right click. I think will give me, what did it just do? A boundary light panel. I just want to sample a lifeline, and they're making me. I don't want a boundary. Oh, regular lifeline. Where is a regular lifeline? The problem is they have too much stuff here. We just want to add a lifeline. Here we are. Okay. Regular lifeline. Okay, so let's say the student wants to get out of here. Okay, so let's say a student wants to take off. So let's say this would be the teacher. Or actually, let make this be the parent. Now I know it's hard to see this. I'll make this bold. And did that go bold? No. But I'll zoom in a little bit. Okay, so now you can see it. So we have the student, right? And we have the parent. And so the student is going to ask the parent for a note, right? So like an absence note, right? So it's going to send a message. Where we could should have a message over here to the lifeline, right? And this will be the parent. And the message will be, please write an absence note. And then the parent will reply to the student with a to a lifeline, but this is actually going to be the student. It's not letting me do it. I'll just say teacher. Okay, now what I'm going to do is I'm going to take this over here. Sorry, they have too many options. I want to take the line over here and get rid of this line. I want to take a line from here and I want to, oh, here it is. Go back here. So something went wrong. Why is it's like some things are very hard to do. So I want to go from the create message to a lifeline, and I'll do lifeline. And I'm going to sort of trick it. And I'm going to take this line over here and what just happened? What just happened to my oh, here we are. No, that's not it. I'll do it one more time. Sequence diagram, blank. I don't know what happened to that diagram. So basically, what I'm going to do is I'm going to create a actor, okay, which is going to be student. And then I'm going to have another, I'm going to take a lifeline over here. I'm going to try to drag it without it driving me crazy. It's not letting me do it, so add a lifeline over here. And then this will be the parent. And the student's going to go from the, it's going to go to the parent. Going to ask for a note. And then the parent is going to, it's a little bit difficult to do. Okay. Okay, is good, it is going to give note to student. And then, okay, now, I have to do is I have to make this a, give me one, stereotype, that's what it is. I gotta change this to, um, type, here we are. It's gonna be reply. Okay, and I'll make it bigger in a second, okay? Sorry if it's so small. Then I'm going to add another lifeline. This will be a teacher. And then I'm going to have one more, which is going to be a principal. Okay, so this will be the principal. Okay, and I wish I could make it bigger. I'm not sure how to make the text bigger. Maybe I could do that. Whatever, I'm going to make it bigger in a second. So what happens is the student is going to send a message to the teacher, or going to send a note to the teacher. Hand note to teacher. The teacher is going to send a note to the principal. Come on. And then ask for approval. And then the teacher is going to reply to the, let me just make this a little bigger. Okay, I'll be, I'm gonna make it larger, so I'm gonna zoom out in a second. I just don't wanna. Okay, so then the teacher is going to reply to the teacher. Oh man, what is just do? It should go over here. Why is it here? I don't know what just did. The teacher should. Oh, because it's not long enough. Okay, we're nearly there. That should send it to the teacher. Why does it do that? That's bad. It should go here. It should go from here to, I'm just going to drag it. There we go. Okay, and it's going to approval, and this is going to be a reply. So we're going to change the type to be reply. And then the teacher is going to reply directly to the student. I'm going to just drag this directly to the student. And then make this a reply. And we'll just say a student receives receives an permission. Okay, so what's going on here? So basically, it's not exactly okay. So over here, something looks wrong. Okay, so over here, okay, let's look at this. So first we have the student who is the first arrow, right? And this should be a solid arrow. I don't know why it's a dotted arrow. So it should be a the type of arrow should be I don't know why it's a dotted arrow. This is wrong. It should, I can't change it. It's it should not be a, whatever, this should not be this is a request. So request is a solid arrow, okay? So this is, let me just, I should get rid of this. Let's get rid of that. Okay. So let's start again. So we start over here and this should be moved down. I'm sorry, I forgot how difficult this thing is to use, especially without a mouse. Okay. Why are there two lines here? What is this line for? I have no idea what this is doing. Lifeline 2. Oh yeah, this, I do want to light. Okay. Okay, so why doesn't it let me drag this down? So I want to have from the student. This should go. Sorry about this. Okay, so, okay, one more time. We start with the student, and the student asks the parent for a note, right? Asks for a note. The parent replies with a, let's go down here. The parent replies with a note to the student. And it's, since it's a reply, so parent gives note. And since it's a reply message, it's going to be a reply, which is a dotted line. You got that? So that's why it's a reply. So the student asked for a note from the parent. The parent replies with a note. Then the next step is because we're just going from top to bottom, the student then takes that note, gives it to the teacher. The teacher then gives it to the principal for approval. then um, then um, the principal tells the teacher about whether it was approved, and finally the teacher sends a message to the student if they're approved or not. Okay? Does that make sense? So we start at the top, right? Then we get a reply message from the parent. Then we send a message to the teacher, who then sends a message to the principal. The principal replies to the teacher, and then the teacher replies to the student. Okay? That's a sequence diagram. So we're going from top to bottom is a passage of time. Now, these things over here are like the parent, teacher, and principal. Those are called lifelines, right? Why are they called lifelines? I never understood it. So I think I figured it out though. See this line over here, this blue part? No, this is like a dotted line, but only some of it is like a rectangle, a blue rectangle. And the reason for that is because during that time, it's active. So it's called like the activation period, right? So that's why it's called lifeline, is because the line, this parent object is only active during this time, right? Gets a message, replies, and then the parent is out of the picture. And then again, the teacher is only really active for, this amount of time. And then the principal is only active a little bit also, right? So like, for example, we could say which object was the least active, it would probably be the parent, right? And you can measure it by looking at how long this blue line is. Okay, so again, so we start from top to bottom, right? And we're looking at messages between the objects, and this solid line is a message, and a dotted line is a reply message. Okay? So that's basically what it does. So it's showing us the flow of messages between objects. Okay? As you can see over here, you could make them a lot more complicated. We're not doing that. Okay? If you want, there's not, you don't want to become an expert on doing diagrams because, unless your boss pays you for it, I guess. But normally, these things change so quickly that, like somebody at work, like for example, they made a MP4 help file, like using AI, about how to use a new feature in our program. And I'm thinking, it's probably out of date already and no one's going to change it. Like they're going to look at this video to learn how to use it and it's probably already been changed. So, no one's going to bother to update it. So that's the thing with these diagrams, is you don't want to spend too much work on them because it's going to change. And when it changes, no one's going to update the diagram. So they have a very, limited value, a limited, their, I forgot the word for it. They're time sensitive, right? They're only have a value for a very short time. So like, we take an X-ray of a person, that's how they were when you took the X-ray. The next day, they could have changed. So the X-ray only shows like a moment in time. So these things are sort of the same thing, meaning that this just shows you what we thought today, how the system should work. How we thought it's going to work tomorrow, that's probably a different diagram, right? Or slightly different. So that's why Uncle Bob says don't spend too much time on these things, because it's basically, don't learn all these things on the left, because all this stuff is just gonna, the more work you put into this, the more you have to maintain it. And also, because very few people understand what all these things do. Like, it's like, the person who did it might understand it, but so that's why I'm only teaching the really basics, right? Because you shouldn't should not spend a lot of time in making fancy diagrams, right? Should always try to be, okay? Okay, so we're gonna finish, next week we'll finish with state diagrams, and then we'll do architectural, patterns, right? So it's, right? Okay. So, okay, so I'll see you, next week, okay? Now, I should do the grades over the weekend, as well as the reasons why I gave the grades with it. If there are any, if there are any reason. Okay. So have a good night. Not sure what I changed.